Hello, in our first video of basic organic chemistry, we have done different concept of basic organic chemistry. When we are learning basic organic chemistry, we have reached at the stage where we have done reactions. Now, when reactions are taking place, we have done there are only four different types of reaction: substitution, addition, then elimination, and last is rearrangement. These are the four different reactions. What is the common thing in the reaction it is taking place? That also we have done. The reaction is nothing but it is the breaking of the old bond and formation of a new bond. So breaking of old and formation of a new, this is taking okay. But now, as good as we are learning or doing various reaction, we are coming across a various concept, such as we are concept carbocation. We are coming at another concept carbanion. Then free radical. After that, we are coming at the concept known as nucleophile, electrophile. What this concept means and how we are reaching up to this concept by this reaction. See, any reaction is having four parts: reactant, any reaction, reactant plus reagent gives product, and this is byproduct. Now what is going to happen? This reactant actually which is present, this is going to break. Reagent is also going to break, but reactant is going to break in another form and reagent is going to break into another form. Then one of the part from this, it will combine with this, or another part will combine with this. So basically, a reactant is breaking in another part and reagent is breaking in another way. This breaking and approach, it is known as mechanism of reaction. So that mechanism we are going to discuss afterwards. So what is the thing that making that reactant, the bond of reactant and bond of reagent, what is the thing making that bond to break, and after breaking of this bond, what is going to form? So now we are going to learn the concept of bond breaking. In a reaction, if reaction has to happen, bond has to break, and this bond breaking process, it is known as a very interesting word. It is known as bond fission. So if bond fission will take place, then and then that bond will break. That what are the different conditions? That you know that in the reaction and reagent we are using solvent also. So sometimes this bond is done weakened by either reagent, either that solvent, that bond is going to break. That's it. So now we are going to learn detail bond fission. First of all, we'll clear the concept known as bond fission. Dear student, I have told you that in our organic chemistry, we are having sp3, sp2 and sp carbon. And we are having carbon-carbon single bond, carbon-carbon double bond, and carbon-carbon triple bond. Now, actually, if reaction has to take place, this bond has to break. Now, there is a presence of two sigma electrons. So, when these sigma electrons are there, in this, along with there is a presence of one sigma and one pi. Out of that, sigma bond is stronger than pi bond. So, when breaking it takes place, pi bond will break first. So, pi bonds are loosely bound. Now, this bond fission takes place, this is going to break. But I want to tell you this bond fission is of two different types. This bond fission is of two different types. This bond fission is of two different types. Homolytic fission and heterolytic fission or heterolytic fission. What is meant by homolytic? That all of you know that covalent bond is made up of two electrons. This covalent bond is also made up of two electrons. I'm not writing. See if what is going to happen. Let me tell you that when we are going to show the flow of electron, we have to show such a type of curly arrow. If you want to show flow of only one electron, we have to show with the help of such a type of arrow. Now, if you are showing this bond and if you are showing this bond to this, it means this bond is broken. This bond has broken. This carbon and this carbon, please see this bond is taking both the electron. One lone pair of electron is equals to one single bond is equals to negative charge. This concept you have to keep in your mind if you want to understand this reaction mechanism very easily. So what is going to happen when this is going to happen? So definitely it will get both the electron. Please see, I am showing you how to understand the mechanism. And now what is happened? Now what is happened? This carbon, there is no electron, so it will get a positive charge. If one bond is there, and consider that if you are showing only flow of one electron, so you have to show with the help of this arrow. So if one electron is going on this carbon, definitely another electron will go on this carbon. So if it will go, this both the carbon will get it one electron. See, actually you should learn the use of arrows. So when homolytic fission will takes place, equal distribution, and heterolytic fission takes place, there is unequal distribution. Homolytic fission when takes place and there is equal distribution, please see this carbon, this carbon, this carbon, this carbon. Both carbons will get one electron each, and this carbon will get positive charge as I have told you. And please see, you should understand flow of electron. So homolytic fission gives species with one electron each. It is known as free radicals. And this heterolytic fission will give charges. So if there is a presence of positive charge on carbon, it is known as carbocation. If there is a presence of negative charge on carbon, it is known as carbanion. So any reaction, and if carbon contains electron, it is free radical. If any reaction has to takes place, definitely that reaction there must be a bond breaking, and when bond breaking takes place, when bond breaking takes place, there is a formation of either of these three radicals, three species. So these are known as reaction intermediate. These are known as reaction intermediates. Reaction intermediates means any reaction, if reactant has to break, either it will break into this species or it will break into this species or it will break into this species. This is known as carbanion. This is known as carbocation, and this is known as free radical. Dear student, carbocation, carbanion and free radical, it is formed by reactant. Now consider if you are having a reagent like HCl. This HCl, when bond fission will take place, it will form H plus and Cl minus. So there is a no carbon. So this is known as electrophile and this is known as nucleophile. Another most important thing, that carbon also can play, it can act as a nucleophile also. So that is another story. Nucleophile, we can having both. Now we are going to discuss this intermediate will form. Definitely, I think you have heard about aldol condensation. Aldol condensation proceeds via carbanion. SN1 reaction proceeds via carbocation, and photo and free radical reaction go with this. This carbanion, it is having sp3 hybrid orbital, sp3 hybridization. It is having sp2 hybridization, and this is also sp2 hybridization. So as in the carbanion, please see, this is the carbanion and there is a negative charge. So it is having a electron donating capacity to form the bond formation. So any species which will give electron density to the carbon, it is known as nucleophile. Nucleophile is the species which gives electron density to the carbon. Now these species, it is sp3 hybridized. And how these, which are the factors making these species active? First of all, we'll discuss nucleophile and electrophile. Lastly, first of all, which are the factor making this carbanion carbocation reactive or stable? One thing you should understand, more stable, it is less reactive. And if less stable, it is more reactive. Now consider, we are first of all discussing carbanion. This is carbanion. This carbanion, there is a presence of a negative charge. First of all, we'll go for inductive effect, plus psi effect. Now if this negative charge is there and if there is a presence of methyl group, so what is going to happen? This will give electron density to this. What is going to happen? The magnitude of negative charge will increase, and when magnitude of negative charge increase, this carbanion will be more reactive. So it is not more stable, it will be more reactive. Now after this, if you are having Cl, and here it is minus, what is going to happen? This carbanion, there is a presence of minus psi effect. So this carbanion is not this much reactive, so it is stable. So dear student, minus psi effect and minus R. So you can go for comparison of this carbanion also. Another most, this is the inductive, will go for resonance effect. The resonance effect. When we will go for resonance effect, all of you know that, consider there is a presence of carbanion and there is a presence of such a type of thing. This ring is having its like this. It is not having like this because it is rich. So what is going to happen? This carbanion will go inside. And because of the minus R effect of the ring, there is a delocalization. So this is becoming stable. So this ring is having its minus R effect. Consider you are having carbanion. You are having a carbanion, and that carbanion, basically that carbanion is having electron donating group at para position. What is going to happen? This will go to this will go to this, and this will go. So it is making this carbanion more reactive. So in this way, plus R and minus R, so it is having its plus R effect. So plus R effect will destabilize, minus R effect will stabilize the carbocation. Now dear student, many reactions are there in which the carbanion, see carbanion is acting as a reactant intermediate, many Perkin reaction, aldol condensation. In that reaction, what is going to happen? First step is this H is there, that base OH minus will abstracting this proton, and there is a formation of a carbanion in many steps, and this carbanion is acting as a reaction intermediate. So I want to tell you that which reaction in which we are having reaction intermediate as a carbanion. So this is the first thing. Why it is forming, how it is forming, how it is going to react, that is the different story that we'll discuss afterward. First of all, you understand the reaction intermediate as a carbanion and how it is becoming stable and how it is becoming a reactive. Another second, the reaction intermediate, second reaction intermediate is that second reaction intermediate is a carbocation. I think you have heard about two different types of carbocation: classical carbocation and non-classical carbocation. So classical, planar, non-classical, non-planar, that is okay. But regarding the carbocation is having 3 sp2 hybrid orbital and p orbital, which is perpendicular to plane, where there is a presence of positive charge. This carbocation is sp2 hybridized. Dear student, carbocation formation of a carbocation, all of you know that formation of a carbocation is important step in SN1 reaction. The formation of carbocation, why it will takes place, how it is taking place, it is depend upon polarity of this bond, whether it is depends upon inductive effect of this bond. This is a different story. But the thing is that formation of carbocation. This formed carbocation if there is a presence of a positive charge. And consider there is a presence of plus I effect. Dear student, what is going to happen? This group gives electron density to this positive charge. So what is going to happen? It makes this carbocation more stable. Now consider this, there is a presence of Cl, Cl and Cl. Now this positive carbocation, this will going to act minus I effect. So as they will pull electron density, this carbocation will be more deficient. More deficient means it will be more positive, and more positive means it will become more reactive. So this is the second most important thing, that is known as carbocation. Same thing when you will go for carbocation and there is a presence of electron donating group and there is a presence of electron withdrawing group. Now here this ring is having its plus R effect, and here this is having its minus R effect. More minus R effect, there will be more deficiency in this carbocation. More deficiency means it is more reactive, and here it is less reactive, stable. Dear student, you should understand which is reactive and which is stable. Which is reactive, that will more stable. So these are the different factors that is affecting on carbocation. Last species is a free radical, and it is also getting stabilized. This is free radical. This is also getting stabilized by same like our carbocation. Stability similar like a carbocation. It is like a carbocation. So these are the three reaction intermediate we have discussed. So now you see, you can draw delocalization like this. Here there is a presence of plus I or minus I, so it is becoming more reactive. Okay. Now we have done three reaction intermediate. Every reaction intermediate is forming into different reaction. For example, I'll tell you how reaction intermediate is forming. Consider you are having this reaction. Consider you are having this reaction. It is a very famous aldol condensation reaction. Every reaction intermediate is forming. Please see what is going to happen. So in this reaction, there is a formation of a reaction intermediate, and this reaction intermediate is a carbanion. Just see, I have written one example. Another reaction I am going to write down, BC, Br, and if I am going to proceed this reaction, in this reaction there is a formation of a carbocation. So this is SN1 reaction. So every reaction is proceeding via, or you take any photochemical reaction or any photo reaction, consider there is a presence of CH2 and H, and if this reaction you are having photo light, you are getting free radical. There is no any reaction that is proceeding via reaction intermediate. So first most important thing, it will form a reaction intermediate. It is okay. So you understood reaction intermediate. Now another most important thing, I want to tell you information about nucleophile and electrophile. Now nucleophile means electron rich species. Nucleophile means electron rich species, and it is electron deficient species. Definitely it will attack on reaction intermediate. Consider if there is a formation of carbanion and if there is a presence of electrophile. So definitely this will attack on this. Just see, negative charge is 2 and there is a formation of an bond. Another most important possibility that, see, this is carbocation and this carbocation, and consider there is a presence of nucleophile. So it is like this. So carbocation and nucleophile. Dear student, you have to see, you have to always show flow of electron from rich to deficient. So A, B. B is not having electron, A is having 2 electrons. So these electrons used for bond formation. So in this way you can understand mechanism also. Now another most important thing, if a species electrophile and if that electrophile is having plus I effect and if that electrophile is having minus I effect. If it is having plus psi, that plus psi effect will decrease the magnitude of positive charge. And if there is a presence of minus psi effect, so it will pull, it will pull, it will pull. So magnitude of plus psi effect will increase. So definitely this electrophile is more stronger. In the nucleophile, it's not like this. Consider in the nucleophile that if you are having these two nucleophiles, it is carbanion also, it is also nucleophile. There is a presence of plus psi effect is greater, so this is more stronger nucleophile. You can discuss the different examples of nucleophile and electrophile. So in the next lecture, we are going to discuss how this nucleophile and electrophiles are attacking on the reaction intermediate and where the reaction is taking place. How to perform reaction mechanism and what is the use of different reaction intermediate that we are going to discuss. In that also we are going to discuss what is the difference between base and nucleophile also. So if you have liked my lecture, please like it, press bell button and subscribe it. Thank you very much. We'll meet in the basic organic chemistry lecture 3. Thank you.